Solid wall insulation is now a priority in the UK. Most houses built before 1930 have solid rather than cavity walls. Consequently, they cannot be treated with cavity wall insulation. This applies to around 30% of all houses in the UK. This terrace house in Skirton, Lancaster, built in 1900, was chosen for a demonstration of energy efficiency measures. The project was organised by LESS, a community interest company promoting sustainability in Lancaster, with funding from the UK Government's Department of Energy and Climate Change. The work was carried out by the Better Roofing Company. Heat will be conducted out of a house through the roof, the walls, the windows and the doors. Heat loss will be increased by drafts and by convection, particularly hot air rising up the chimney. The first step in this project was to conduct an energy performance certificate survey to see where heat was being lost and what cost-effective measures could be taken to reduce this. An EPC will give the house a rating for its energy and carbon emission efficiency, ranging from A for the most efficient to G for the least efficient. The average rating is D. The house owner has already taken a number of energy efficiency measures, including fitting double glazing, insulating the loft to current standards with 300 mm of mineral wool insulation, and applying cavity wall insulation to a single-storey bathroom extension built in the 1960s. This work was carried out as part of the current LESS project and funded by Lancaster's Warm Homes Insulation Scheme. The current rating of the Skirton house was D62. The potential rating was D64. This modest increase in energy performance was based on the recommendations of a basic EPC, but the energy-saving measures now being introduced into the house are expected to bring it close to a B rating. Visual inspection and thermal imaging revealed a number of problem areas. In the external walls there were large stones that formed thermal bridges between the inside and the outside of the house. These are shown as dark areas in this thermal image. The house was drafty. The dark area in this image shows cold air coming under the back door. The single-storey bathroom extension had a flat roof with minimal insulation. The pale stripes running across this thermal image are the wooden rafters, which are significantly warmer than the rest of the ceiling, either through faults in the original construction or caused by decay or subsequent repairs. There were numerous voids and gaps which would admit drafts. And, although the double glazing units were good quality, the fitting was often poor, allowing heat to be lost around the sides of the units. This is clearly shown by the dark area in this thermal image. Within the budget for the demonstration project, the contractor was able to remove the ceiling in the single-storey extension, insulate the flat roof structure using Celotex, which provides a greater degree of insulation than mineral wool within a restricted space, and then replace the ceiling. Draft-proof the house, mainly by removing skirtings and other fittings to uncover and fill voids. Fit a chimney balloon to prevent heat loss up the flue, and apply solid wall insulation to the inside surface of the exterior walls. This was the major part of the contract. Insulation fitted to the outside surface of the wall is more thermally efficient, but this would not have been visually attractive, particularly as this was one house in the middle of a terrace. Also, if you fit external insulation on just one terrace house, you would get cold bridges for the adjoining properties. It's more effective to fit external insulation along a whole terrace. Because the rooms were quite small, approximately 3 metres by 3 metres, it was important to sacrifice as little space as possible. The solution was to attach 50mm Kingspan Cooltherm K17 insulated plasterboard panels using the dot and dab technique. This maintains a clear cavity between the board and the exterior wall, which also helps resist moisture penetration. Cooltherm boards are CFC, HCFC free and have zero ozone depletion potential. The walls are then skimmed with plaster and the skirtings and other fittings replaced. The window openings were also treated, but the side walls, shared with the neighbouring houses, were not, as this would have produced little saving. It is hoped that these measures will result in an improvement in the EPC energy efficiency rating from D to a high C or low B. In a typical house of this type, this should save the owner around 30% of their energy bills. I-button sensors are being fitted to monitor the building.